What's yours on? Excuse me?
It's on 1.
It's on 1?
It's president.
1.
It's on 1.
Should I turn the light off?
Yeah, you can.
No.
You can see the camera.
1, 1.
Yeah, where's 2?
Fibonacci sequence.
Oh.
Oh, I love it.
13.
So,
21.
16, 16,
21.
15, 15.
21.
So, what do these numbers represent?
Fibonacci.
Okay, good job.
I had no idea.
Okay, so within the Fibonacci sequence, there are some pretty cool things that you can investigate. So, what is it and how is it formed?
I don't know.
It's a rhetorical question.
So,
Never answered.
Yeah, it's a rhetorical mean.
good thing. Insane.
What's wrong?
It's just like one of the slides got skipped.
This is gonna mess up the whole thing, isn't it?
No, it's not. It's just dragging it.
Okay, so.
Whoa.
Okay, so the Fibonacci sequence is formed by adding the two previous terms together. For example, if you start with 1, you would say 1 plus 0 equals 1. Then you add 1 to that, so you get 1 plus 1 equals 2. You add 1 to that because that's still the previous term. So you get 2 plus 1 equals 3. You add 2, you get 5. You add 3, you get 8. You add 5, you get 13, and so on. And it is a very simple concept, but why is it so important? So, it's important because it appears almost everywhere in nature. In plants, not only in flowers, like follow the pattern, but also the stem and its leaves also follow the pattern. So let's investigate.
There's little numbers on.
So in this, this is a sunflower, and there are 2 consecutive Fibonacci numbers. If you take the spiral used, like if you start from the center and then spiral outward to the right, you would get 21. If you go to the left, you would get 34. You would find 34 Fibonacci spirals, which we'll talk about later. And so, also, if you were to start from any one leaf on a stem and go around it, counting the revolutions along the stem until you get to one directly above it, you will get another Fibonacci number, because that's 1 revolution, then 2, then 3, then 4, then 5, and so the eighth leaf is the top leaf, and it's also a Fibonacci number. So those are some cool examples, but does it occur in the life of animals?
No.
It actually does, and it can be seen in the breeding patterns of rabbits. So, yeah, like,
Whoa.
so after 2 months, a rabbit matures and can have 1 pair of rabbits every month after that. So, considering no one dies, so you have this original pair. Then after 2 months, they have a pair of rabbits here, and then they, after another month, have this pair, and then after another month they have that, and then after 2 months they have these. Okay, right.
Nasty animals.
And so basically, at the end of a certain period of months, like if you're, you will also have a Fibonacci number, assuming none of the rabbits die. And so the Fibonacci can also be used to derive the golden ratio, which is like, okay, that's great.
Rabbits are cute.
And so, if you take 2 consecutive terms and divide the larger by the smaller, you will get close to the golden ratio, which is 1.618034. And so, here are some examples. 8 divided by 5 is 1.6. 13 divided by 8 is 1.625. 21 divided by 13 are 1.6153842. And so, all of these numbers are pretty close to the original golden ratio. Along with the golden ratio, you can derive the golden spiral from the sequence. And so this is basically derived if you take the Fibonacci numbers and you create like the first one starting with area of like side length of 1 each, and then that's 1, that's 2, so on, 3, 5, 8, 13, 21, 34. And if you connect the opposite spirals with if you connect the opposite corners of the squares with a 90-degree arc, you will get a golden spiral, which is like the perfect spiral.
So if you kept going, it'd be like Gary's snail.
What? Yeah, it'd be a like infinite spiral.
Oh my god. Dude, Gary's snail is my favorite. Cool. No,
Yeah, so there are many formulas that can be derived to find the nth-determinant sequence, but they're all very complicated and hard to understand. And so,
I'm going to
Yeah,
do
really. If they're all
just adding
complicated, then none of us will know it.
Yeah.
Bum bum bum.
and so,
Stop
yeah,
being smart on it.
thanks for watching.
No problem.
And